In this episode of Tech Effect, working in the smart factory, life-saving drone technology, and why it might not be long before your new co-worker is a robot. First, training workers for jobs of the future. Our work and leisure is requiring increased connectivity, leading to a huge expansion in digital networks. As the world's internet capacity grows, so do the opportunities to innovate every aspect of our lives. Global technology company ABB is applying the concept of innovation to its training facilities, with the aim of preparing graduates for a new world of work. The company's German trainees learn everything from advanced robotics programming to 3D printing and modeling. It's likely that their future will involve working with smart digital technology.
Every day we work with computers and we use a lot of programs in it. It is very important because, like when you see 10 years ago, the smartphone, we didn't have any. We had like Nokia phone. And now when you see we have smartphones, we can touch them and we can do everything with that. And I'm pretty sure that next year it will change a lot.
Around 800 apprentices train at this ABB facility in Berlin. When it was founded 65 years ago, emphasis was on traditional techniques of welding and metalwork. These have now been eclipsed by state-of-the-art digital and automation technology.
The industry is changing and the skills have to also change. World-class products and world-class technologies needs world-class experts, and we train them here.
At a time when the technological revolution is changing factories and offices, technology firms are finding that it's never been more important to ensure a skilled workforce is ready for the challenge. That's good for workers facing up to a new kind of labor market. And as the fourth industrial revolution gets underway, it's also good for business.
Training has always been absolutely key. It's not the first industrial revolution, and training has accompanied our colleagues over the decades, actually over the 125 years ABB has existed. So I guess we're not only focusing on our business, but we also have a role macroeconomically, macro-socially.
The skills learned in centres like these are crucial to the next generation research and development work that tech companies are bringing to market. Like ABB's smart sensor, which allows remote monitoring of industrial motors, or the Internet of Things interface software, both products developed by researchers in India. Translating cutting-edge training to cutting-edge research is one way of showing how the digital revolution can best be harnessed. European leaders are also challenging their citizens to dream big and create new concepts for the digital revolution. The European People's Party, or EPP group in the European Parliament, is working to boost funding in research and innovation to make it easier for visionaries to bring their ideas to market. German MEP Christian Ehler believes investing in innovation could contribute to solving some of the world's most intractable problems.
We put an emphasis in terms of the budget on innovation, and this is the biggest innovation program in the world. We are going after the big things for the first time. So cancer, for example, we have a huge problem with children cancer, and the program will have a mission that means a big effort, €1 billion, where we try to cure children cancer.
Ehler wants to speed up the approvals process so clever ideas can reach the market quicker.
Fast track means simply you go to the commission, you have a consortium, you have a brilliant idea, you have an innovative idea, and they tell you within 6 months whether you get funded or not.
Michal Boni co-authored legislation to boost internet connectivity. He says a 5G mobile system will drive innovation in a gigabyte society with the Internet of Things.
Could you imagine the self-driving cars without sending information in milliseconds? Could you imagine new health solutions as telemedicine platforms?
A former Polish minister for digitalization, Boni says the cloud can help companies large and small.
We need to engage, to encourage SMEs to use all possible digital tools. And this is one additional issue which is important when we are talking about cloud. This is the initiative on European Open Science Cloud, which will give the possibility to all centers of research, to all universities, to exchange information, data, and results of research.
Innovation is leading a constant improvement in e-government and e-health, cybersecurity, and urban planning.
E-government can give you the possibility to participate in decision-making processes on e-health. I think that it will be the game changer. If we will use 5G and also all those new applications and new opportunities, giving to us the personalized medicine, giving to us better, deeper diagnosis, and after this, better therapies.
And why not a European digital library or a university for innovation? MEPs say innovation is limitless in a digital world.
We have joint efforts in the big things, and I think that's an EPP idea, that we go on plastic in oceans, that we care about the next generation of IT, quantum computers. We want to have a quantum computer in 2030. So go after the big things, join efforts, and be competitive in a even more competitive global world.
We need as EPP to address our message on innovation as message addressed to all people, to every citizen, to every patient, to every resident of the small city and the big city, to every worker and to every entrepreneur.
Coming up, finding space for experiments. Among the many innovations that are transforming our working world, drones are among the most useful and the most versatile. They're being used by first responders to save lives, by conservationists to protect the environment, and by scientists and researchers looking for new ways to preserve and protect our global habitat.
Year after year, we've seen drones being used in more places throughout the world. I think about first responders, who at this point have saved over 250 lives with drones. And I also think about rangers in Africa. With a drone, they can now manage and protect elephant populations in ways that keeps everyone, human and animals, out of harm's way. We see drones empowering organizations in new and creative ways every day, and the uses continue to expand.
DJI was founded on specific principles like empowerment and inspiration. As advanced as we made a drone, it's ultimately a resource to fit people's needs. What always impresses me is how our users have taken this tool to turn their bold ideas into action. These people are more than just pioneers. They're proof that innovation isn't just driven by technology alone, but the people who use it.
What I love most about the stories of our drones is how they've inspired people to discover themselves. Many people have started their own businesses with drones. Those with limited or no mobility have found their wings with a drone, rediscovering the world and creating their own paths.
But it's not just drone operators who have big dreams for aerospace technology. Swiss 7th graders, Elias and Mark, represent a new generation whose ideas are ready to take flight. the classmates produced a written proposal detailing their concept for an electric-powered commercial aircraft and sent it to Airbus.
We are fascinated of the airplanes which are now in the world. They are flying, and yes, and then we also like the planes which will be in the future on the Earth.
Airbus Chief Technology Officer Grazia Vittadini was so impressed that she invited them to tour the head office in Toulouse.
These will be the customers and engineers and hopefully pilots of the future. And so it is important that we are on the same page. And definitely we see now in the younger generations a growing interest when it comes to environmental awareness and sustainability. And this is definitely where Airbus is. This is something big on our minds and into our hearts.
Prioritizing safety, connectivity, and zero-emission flight, the boys' concept put them at the cutting edge of aerospace design. Future engineers like Elias and Mark might choose to look even higher than the skies for their career. Already, scientists are using the International Space Station to run experiments for a range of applications, including growing plants in microgravity. As well as solving Earth-based problems, biological experiments will help scientists work out how to feed astronauts on long-haul missions.
So the International Space Station, as its name suggests, is international, and basically it allows you to do very long duration experiments in the spaceflight environment. So looking at the effect of microgravity, low gravity, also exposure to the direct space environment. You can do research in all fields. You can study, of course, the astronauts, how they react to the space environment. So studying the changes in their physiology. You can study biology. So the cells, which would be cells from, say, human body, microbes, plants. You can study also physical sciences, materials science, fluid physics, and also, of course, you can look outside from the space station. You can look at the Earth, so you can do Earth observation. You can do also observation of the space environment. Nice thing is, because it's an international platform, all of the facilities, all of the instrumentation is shared. So that allows you then to do a lot of research and very internationally. So there's been about 3,000 experiments done over the lifetime of ISS. And those gave about 2,000 scientific publications. One of the areas, of course, of interest is astrobiology. Do microorganisms or microscopic animals in dormant state, can they survive exposure to the space environment? This is very important to see whether life could be transported from one planet to another on astronaut, or whether also if you have, for instance, microbes on a spacecraft going from the Earth to Mars, how do you prevent contamination? The other aspect is also, how did life originate? So there's a lot of studies on the chemistry which led to life, so which may have been going on the primitive Earth or on the surface of a comet. So we developed an instrument called EXPOSE, and this was put on the outside of ISS and allowed exposure to direct space environment for typically 18 months, 2 years. And what was found was, in fact, that many of the microbes and even simple animals such as tardigrades, these are water bears, could actually survive direct exposure to the space environment for 18 months or so. And so that was a very interesting finding. The other area, of course, is plant biology. And there was actually a whole series of experiments done over a 10-year period by a team of European and US scientists. And they looked at all sorts of aspects of plant biology. They looked at how plants responded to gravity, because what you can do on board of the ISS is you can effectively look at what happens in the absence of gravity. You can apply, using a centrifuge, artificial gravity, and then see what is the perception threshold for plants to gravity. And that was actually found to be, hundreds of normal Earth's gravity. So plants are very sensitive. Space is also the ideal site to study the process of boiling.
Boiling is encountered in many engineering fields such as environmental applications and industrial chemical processes. Understanding the dynamics of boiling is essential to improve energy production and conversion in power plants, and design future space applications like cryogenic fuel storage and propulsion. Boiling occurs in a wide range of situations, but on Earth, its properties and effects are too fast to be accurately observed and measured. But experiments conducted in low-gravity environments, like on the International Space Station, allow us to observe phenomena like phase transition and the onset of bubbles much more clearly.
We investigate these boiling processes in space mainly for two reasons. First of all, because today's design methods are based on empirical knowledge and not really reliable when choosing, for example, new fluids or sophisticated microstructured wall geometries. Doing experiments in zero-gravity environment has the big advantage that the boiling process takes place in slow motion. That means we can investigate more details with higher resolution than on Earth. Second, modern space technology makes use of more and more electronic devices that have to be cooled very efficiently. Flow boiling is an excellent process to do so. In a team of European scientists, we tested many different components and preliminary setups in our labs on ground, as well as in many parabolic flights. This has led to the final experimental setup of Ruby. Ruby is an experiment to study the basic heat and mass transport phenomena in pool boiling and flow boiling systems.
Performing tests in microgravity conditions is necessary to better understand the boiling process. Such studies may lead to the increased energy efficiency of several applications here on Earth, from power plants, thermal management systems used in electric vehicles, laptops, and smartphones. The opportunity to conduct experiments in space opens a new world for scientific possibilities. Even school students are able to book a place to transport their studies on the commercial SpaceX spacecraft. This moves our horizon from the Earth to the universe beyond. Coming up, factories of the future. Our working world has been disrupted by technology to the extent that it's estimated 47% of today's jobs will disappear in the next 25 years. But data scientist is a profession that has a bright future.
Any company around the world is actually using data to improve their business. So the question is, how do they deal with that data? How do they manage these volumes of data that nowadays we are massively collecting? Data is the new oil, but it's also true that you have to extract oil, you have to transport oil, you have to do everything that we already did with oil.
Other jobs in demand include business translator, who works out the questions to ask a data scientist, and agile coach, who helps companies maximize their flexibility. Finding the right people to fill these positions is a competitive business.
Our competitors in talent search are not only companies of our sector, are all of the companies from different sectors. Today, we have to go to search for them, to find them, and to convince them so that they want to come to work for us.
A car has 100 million lines of code, more than an F-35 fighter jet. So one of the most important jobs of the future in the automotive industry is software developer. Spanish car maker SEAT has trialed a program to give 5 production line workers intensive training in software programming.
I came to SEAT 9 years ago and have been in workshop 8 until today. Here in the electronics lab, we make sure the machines on the line work properly. Today I'm starting a new path.
The trainees start their intensive course a little nervously. but quickly adapt to the new environment. If this program is successful, it will open new careers to many other car workers.
Our goal is to show that we're able to get people like this so they can help us in different roles, potentially bringing additional value.
3 months into the 4-month program, and the trainees have exceeded the expectations of their teachers.
At SEAT, we believe in our internal talent, so to transform our employees means they'll be 100% committed to the company.
These 5 graduates were the first, but they won't be the last. The company is committed to working with its employees to keep ahead of the curve and enable as many as possible to retrain in jobs of the future. And it's not just humans that need to adapt to technology. Factories themselves are transforming. Industry is one of the world's largest consumers of power, so many factories are becoming self-sufficient by installing solar panels or their own renewable power plants. In the factory of the future, the boundaries between human and machine are more fluid, and their interaction becomes more intelligent. We'll see digital assistance systems such as augmented reality, gesture control, wearables, or cobots becoming commonplace, as well as industrial robots that can interact safely with their co-workers without needing protective space. Intelligent gripping systems are now indispensable in human-robot collaboration. With sensitive robotic hands controlled only by gestures, in the future, workers will not have to use programming or complicated software. The next few years will see human and machine getting even closer, with less separation between human work and machine work. Processes are being redefined and reinvented, so humans and machines can collaborate more intelligently. On the production line itself, robots are already taking a load off workers and completely taking over some of the more hazardous jobs. In this Siemens factory, hundreds of robots are working to produce cars. They can handle capacity ranging from 16 to as much as 550 kilograms. The fourth industrial revolution means that the most effective factories of the future will combine both human and machine ingenuity. But we're not likely to be competing with robots. Machines will still need people to design, program, and operate them. The future is about using worker skills in more clever ways. Logistics company DHL's vision is to integrate new technologies such as augmented reality and 3D printing into its warehouses. The company plans to use artificial intelligence and the Internet of Things to make its workload more efficient. Robotics and automation will reduce the need for workers on the ground, freeing them up to work in the e-commerce areas where there is an opportunity to build bigger markets. The workplaces of the fourth industrial revolution will use human ingenuity to deploy machines in the most effective and efficient ways. Instead of the grunt work of factory labor, workers will expand their problem-solving skills and fill higher tech jobs that provide better pay and more interesting positions. Now that's a clever idea. The Tech Effect shows us how we can unlock tomorrow today.